We think of space as where things are, a location, a destination, and we think of time as when they happen, a moment, an appointment. 3 dimensions for here, 1 for now. It feels so natural, so fundamental. But what if that clean split is an illusion, a convenient fiction our minds have constructed? What if the universe is built on a deeper, more unified principle? Tonight, let's tug at the very fabric of reality and watch it morph. Because if you try to pull space away from time, the cosmos, politely but firmly, says, no. Here's why space and time cannot exist separately. For centuries, we lived in Newton's universe. Space was a rigid, unchanging stage. Time was a universal river, flowing at the same rate for everyone. It said so. It was simple, it was intuitive, and it was wrong. A century ago, Albert Einstein shattered that old picture. His former teacher, Hermann Minkowski, then framed the new one, declaring, henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. Not space and time, but space-time. Motion is the key that links distance and duration so tightly that you can't change one without the other responding. Rulers and clocks are no longer independent, they become a matched set, 2 different ways of reading the very same 4-dimensional geometry. The first casualty of this union is our idea of now. Consider simultaneity. Imagine 2 distant flashes of light that seem to happen at the same time for you standing still, but for an observer flying past you in a spaceship. Those 2 events will not be simultaneous. One will happen before the other. Why? Because their motion forces them to slice through space-time at a different angle, creating a different personal now. There is no universal clock hiding behind the stars, no master metronome ticking for the entire cosmos. Every observer carries their own time. If there's no universal now, what stops the universe from descending into chaos? Causality. And light draws the boundary. Picture a cone of light opening up from every event in spacetime. Inside the future part of that cone are all the effects you can possibly create. Inside the past part are all the causes that could possibly affect you. This is your causal neighborhood. But outside that cone is elsewhere, a vast region of spacetime that you cannot influence and that cannot influence you right now. No signal, no information, no force can travel faster than light to bridge that gap. Try to split space from time, and the cone snaps your map back into place, preserving the sacred order of cause and effect. Motion tilts that cone in your diagram of space-time. As you move, your perception of space and time must adjust to keep the speed of light, the slope of the cone's edge, constant for everyone. This isn't just an abstract idea. You can feel an echo of it in the Doppler effect. As a siren approaches, its sound waves bunch up, raising the pitch. As it moves away, they spread out, lowering it. Light does the same. Ahead, waves bunch into the blue. Behind, they spread into the red. You don't need equations to feel it. Blue toward, red away. But the moral is deeper. Space and time themselves must rescale together, stretching and squeezing in perfect coordination, to keep that light cone structure intact for every single observer. That's precisely why lengths contract and clocks dilate. These aren't strange, separate phenomena. They are the direct consequences of preserving causality. Change your speed and rulers you observe must appear to shorten along the direction of motion, while the time between ticks on moving clocks must stretch. It isn't a trick of vision or a mechanical failure. It's the geometry of spacetime itself, insisting that cause must always, for everyone, precede effect. It's the price of a consistent universe. The visual effects are even stranger. Look closely at nearby objects as you move past them at near light speed. They don't just appear squashed, they seem to rotate. This is the Terrell effect. It happens because light from different parts of the object, which left at different times, all arrives at your eye at the same instant. The light from the back of the object has had longer to travel, so you see a part of it that would normally be hidden. Space and time collaborate to draw what you see, creating a distorted, 3-dimensional view that is both physically real and profoundly counterintuitive. This effect extends to the entire world around you. Distances ahead can appear foreshortened, not because the place itself has changed, but because your slice through spacetime has tilted. The geometry of your motion, combined with the finite travel time of light, conspires to redraw the entire landscape. The universe you perceive is a custom-tailored view, sculpted by your own velocity. And yet, from inside your own frame of reference, everything feels perfectly normal. Your heart beats at its usual pace, your watch ticks off seconds reliably, your coffee break takes just as long as it always does. You feel no compression, no time slowing. It's only when you compare your experience with someone else, someone in a different state of motion, that the discrepancies appear. Your seconds disagree. Your definition of now has slipped. Simultaneity dissolves. Time dilation appears. And the shared moment you thought you had with the rest of the universe reveals itself to be a private one. Even the universe's own baby picture, the faint afterglow of the Big Bang, the cosmic microwave background, reminds us of this truth. This ancient light fills all of space, a near perfectly uniform hum. But, if you start moving, that uniformity breaks. The light in your direction of travel appears slightly hotter, slightly bluer. The light behind you seems cooler, redder. Your motion has imposed a direction on the cosmos, but the underlying causal structure stays put. The light cone keeps score, ensuring the laws of physics read the same for everyone, no matter how their personal map of the cosmos may look. Push your speed closer and closer to light, and the effects intensify dramatically. Space ahead of you distorts into a narrow tunnel, time stretches towards infinity, and your perspective disagrees wildly with a stationary observer. Yet the fundamental rules never break. The light cone narrows, causality holds firm, and space-time remains the single unified stage on which this bizarre play unfolds. At the absolute limit, for a photon of light itself, the journey is instantaneous. From its own perspective, it experiences no passage of time. There is no before, no after, just emission and absorption happening at the same moment. The distance between the star it left and the eye it strikes is zero. That's the ultimate hint from the universe. Time and space are not separate arenas for events to play out in. They are one interwoven fabric, and light traces the very seams of its design. Ease back on the throttle, and the universe looks familiar again. The tunnel of stars widens. Colors return to normal. Constellations relax back into their recognizable shapes, and our everyday sense of a shared before and after feels safe and secure. But the lesson sticks. The experience has changed you. You know that what you see is a negotiation between reality and your own motion. Appearances change. Space-time stays true. The darkness ahead brightens. What was once intensely blue-shifted and compressed now expands and cools. What was red-shifted out of sight behind you returns to view. Your motion changed, your slice through space-time changed, but the shared underlying fabric remained. It's the same eyes, the same ship, the same universe, but a different motion means a different map. Speed doesn't just hurry a trip, it fundamentally sculpts the geometry of that trip, dragging time along with it. Observers will argue forever about distances and durations, about which event happened first, and about how long things took. Yet all of them, in their own way, will be honoring the same, unchanging, underlying structure. Let's recap the core ideas. First, there is no universal now. Simultaneity is relative. Second, light cones, defined by the constant speed of light, fence in cause and effect for all observers. And third, length contraction and time dilation are not independent oddities. They are two faces of the same coin, the necessary adjustments space-time makes to keep the laws of physics consistent for everyone, everywhere, no matter how they are moving. This isn't just abstract philosophy or thought poetry. Our modern world is built on it. Our best instruments demand it. The GPS in your phone relies on a network of satellites, each with an incredibly precise atomic clock. If those clocks weren't constantly corrected for both special and general relativistic effects, for their high speed and their position in Earth's gravity well, the entire system would fail. Errors would accumulate at a rate of kilometers per day, and your map would quickly drift into nonsense. We see it in our largest laboratories too. In particle accelerators, short-lived particles live longer when they sprint. Take the muon. It's a heavy cousin of the electron that should blink out of existence in just over 2 microseconds. Yet, when created by cosmic rays hitting our upper atmosphere, these muons race downwards at nearly the speed of light. From our perspective on the ground, their internal clocks are running so slow that they survive the long trip to our detectors. Time, stretched, distance, reshaped, space-time, consistent. The sky itself is a constant, ongoing experiment. Every second, cosmic rays, high-energy particles from deep space slam into our atmosphere. They spawn showers of secondary particles that cascade downwards, each one bearing the clear, undeniable fingerprints of relativity. It is proof written in starlight and air, a daily confirmation of space-time's strange rules. Think of the speed of light as the universe's immutable metronome. It sets the absolute tempo. When you move, you don't change that tempo. Instead, your perception of the rest of the orchestra's rhythm changes. The beat you move toward quickens, while the beat you leave behind relaxes. Yet the score, the fundamental laws of physics, sounds the same to everyone who plays by space-time's timing. From the outside, your ship looks shortened, and your clock appears to run slow. But from your perspective inside, you're fine. It's the universe that bends and stretches around you. The Earth you left behind looks compressed, and its clock seems slow. There's no privileged view, no absolute right answer. There are only different perspectives, all equally valid, woven through one single, four-dimensional fabric. So, why can't space and time be pulled apart? Because they were never separate to begin with. They are two aspects of a single, deeper reality. Every event that has ever happened or ever will happen has its own unique address in this four-dimensional world, guided by the strict rules of light cones, guarded by the unbreakable law of causality, and confirmed by countless experiments. Return to the starfield, and remember, it's not just space, and it's not just time. It's all space-time.